All right, for lesson number 9, we're going to be doing exponential models, and we have 2 parts to this because we also need to do compound interest. So that will be lesson number 10, but the topic is exponential models. Will all be on one quiz. All right, so let's talk about exponential function. Y is equal to a times b to the x power. That is how you write it in standard form. This a value is your initial point and or your y-intercept. And then the b value is your growth or decay value. And it's kind of like your slope because it tells you how fast you're going to go up or how fast you're going to go down. So let's look over examples of growth. So a growth, your exponential function is going up. Another thing that's really, really important when you're looking at the function y equals a times b to the x, this b value determines if it's growth. So it just has to be greater than 1. Can't be 1, has to be greater than 1. And if we notice that's true, it doesn't matter what your a value is because that's just where you go through the y-axis. So if you have an example like this, again, we're looking at that or the b value. So this number right here, it's greater than 1, so this is growth. Okay, so again, we're looking at just the b value, 8/5. So that can be changed to 1 3/5. So that's greater than 1 again, which is why it's growth. So 1.67 is greater than 1. So again, another example of growth. For decay, your exponential function goes down. And your b value needs to be between 0 and 1. Okay, so now you're talking fractions or decimals that are fractions, whatever, either way. So some examples of that, again, just looking at that b value. This number 0.54 is in between 0 and 1, which is why it is decay. Hold on, let me fix that. All right, so then 0.4 times 1/3 to the x, the 1/3 is between 0 and 1. So notice I put a dot here and not here. It means the same thing. And you need to be really good at recognizing that if some two things are next to each other, if they're using parentheses or if they're using a dot, they're being multiplied by each other. So when it comes to growth and decay, we look at the b value, which is your number that's attached to the x. And that determines if it's growth, if it's greater than 1, and decay if it's between the two. When writing an equation for exponential function, if you have, let's say 4 times 2 to the x. So when you're doing an equation like this, you know that you're starting at 4. That's where it's the y-intercept. So at 0, 4 is where your exponential function goes through, right there. And then it's going up times 2 each time. So if you were to plug in 1, it would be y equals 4 times 2 to the 1 power. So that's 2. 4 times 2 is 8. So now you're going up extremely fast. So we're right here. Let's do a negative number. So we can do -1. Y equals 4 times 2 to the -1. That's going to bring the 2 down. So it's going to equal 4 divided by 2, which is 2. So at -1, we're down at 2 right here. All right. You can just sketch in the rest of it. Like obviously you can put more points in, but it's a growth, so we're going to just sketch it in. We will talk about tables in class and given 2 points, how do we write an exponential function.